The Statistical Manager is a service running in the iMarine gateway which allows to execute data mining experiments. Let's sign in, then we access to the scalable data mining facilities and then to the Statistical Manager. In order to execute an experiment, we click on the button in the middle and we access to the list of available operators which correspond to the available algorithm that we can run. In this experiment we will train a neural network in order to simulate an end port. Select the feed-forward neural network. I previously imported a table representing an end port, and I can click in order to look at the details of the table. Then I set that the first two columns, A and B, that means the columns with the logic inputs, will be the training columns on which the model will learn. As target column, I select the C column. This will be the column that the network will simulate. In this case, I set that no inner neurons will be placed by the network. The learning threshold will be 0.001 and the maximum number of iterations will be 1000. I call the model name as test and port, and then I can execute the computation. I can download the file which was produced by the neural network training session. I can then reuse the neural network by going into the function simulation section. In this section I can take the endport table and select the features that I want to put as input to the network. Then I will generate a distribution where we will gain one row for each of the inputs in A and B. We will ask the system to simulate, in this case, the C column. The distribution will be called distribution and port test. No grouping factor in this case, because we only want to simulate a function that outputs only one real value. As model, we select the previously trained network. I can recognize it by name. Then I start the computation. We can follow the computation progress by checking the computation. In this case, I can look at the details of the computations, as in the infrastructure field I can look at the kind of infrastructure that executed the experiment. Sometimes it is executed on a default science infrastructure using the computational capabilities provided by the cloud computing facilities. Otherwise, it could be executed on local server, so that it does not use the cloud computing facilities. By clicking on one of these records, I can get the output of the distribution. In this case, as you can see, the output of the network is near 1 for the inputs 1 and 1, and far from 1 when the inputs is not 1 and 1. This is a real function that simulates some sort of endport. In the rest of the fields I can get the computation details and the parameters which should allow me to reconstruct and reproduce the experiment. Here you have the operator details, which state what is the output of this procedure. The same output is accessible through the data space. I can recover the file, the trained neural network that was produced by means of these buttons. I can save into the workspace, or I can save locally, or I could retrieve the output that was produced by the network. As you can see here, this is the same distribution. This is the name that I put by means of the interface.